Hello everyone, my name is Kelvin. Today I'd like to talk about my physics 1 lab 2. So it's about the analysis of projectile motion. So here's my table of content. First I'll introduce the purpose of lab 2 and then I'll explain some theories which include 3. And then I'll talk about my practical plan and also the practical which includes video production, tracker analysis and also glow script. And lastly, I will do some data analysis and explain why there's some errors and also some further discussions about my lab. So first of all is my introduction to the lab. So the premise of lab 2 is basically want to analyze the projectile motion using the Newton's second law. And then I'll also create two computational models by glow script to compare it. And then the object will be a whiteboard eraser, which is a very common object, a rectangular cube. And then to observe the motion, we'll use an iPhone to capture the motion and use a tracker to do the calibration. And finally, we will use a glow script to produce the predicted motion. So I'll now explain the theory. So the three fundamental principles are Newton's second law, gravitational force, and also air resistance. So as mentioned in lab 1, we can use the F equals ma to derive the momentum principle, which is a system change in momentum. Delta P is proportional to the net force applied. So delta P over delta T, also the derivative of momentum is equal to F net. And then we can derive the velocity update formula by using that, which is the v final equals v initial plus F net over the mass times delta T. And then it's a gravitational force, so it's an attractive force that will attract things with masses together. So in this situation, Fg is always equals to 0, negative mg0, because it's vertically down. And then the third thing is air resistance, which is quite special and is like acting oppositely to the direction of the velocity, and then it's a resistive force. But remember, for calculating the velocity of a projectile motion, you have to consider the theta. So in this situation, theta might be 30 degrees or maybe 15 degrees, and then you have to calculate the v sine theta and v cos theta for the y and x velocity component respectively. And now I'm going to talk about the procedure of this practical. So first of all, I will do some observation of this a projectile motion and record it with an iPhone. Then I'll put it inside the tracker app, and then but before putting the tracker app, remember for recording the motion you have to use two meter ruler, one horizontally and one vertically for the calibration, and then which is 1 meter. And then after calibrate using tracker, we can use a glow script to produce two predicted motion, one with only G force and one with drag force and G force. And then after all of that, I'll place them into a spreadsheet and then create a graph with 3 curves and then analyze the errors. And also I'll discuss some of the further problems. So and then I'll talk about the practical of the lab 2. So first of all, it's a motion observation of using tracker. As you can see, I use the point dots. So I just point 18 dots to kind of recognize the motion of the projectile motion. And then in the right side, you can see 2 graphs. One is the X and one is the Y position. So you can see the X one is constant gradient, which means because there's no X component of force, F equals ma, A equals 0, and so that the velocity is always the same. And then I can create a table behind it. So after that, I'll create 2 computational models. So I'll create a G-force only model first, and then the most important thing is that you can actually use glow script to create to plot a graph like with the inner function. So it's quite interesting. And in this situation, the only force is negative mg in the y-axis. And then if you want to add the drag force into consideration, you have to let b be a number that you get from experimental data. In this case, I got 0.05. And then remember to add the F drag using the equations to satisfy the situation, which is the F drag equals to negative b times the speed and times the velocity direction. And then lastly is the data analysis. So we can see the graph, which are very similar. There are 3 curves. And then now I will talk about the errors. So errors might include other forces like air conditioning force, and then some rounding errors, and also the calibration mistakes because the angle of shooting video is kind of different. So maybe it's not exactly 1 meter. And then for terminal velocity, and you can notice on the right side, the terminal velocity is kind of calculated with this F drag. So you can see it's exponentially decaying. So it's like the gradient is reducing. So at the end, the gradient will towards like zero, but it will never become zero, but towards zero. So if we throw it straight up, because we can use the Newton's second law and momentum principle to calculate the time flying. As you can see, there's a sine theta for the projectile motion. So as sine theta is not equal to 90 degrees, it's the upward projectile is always longer than the usual projectile. And then if we include air resistance, because the v sine theta, the vertical component of the velocity already reduces the velocity, so actually projectile motion regular is still having less flying time than the upward motion. So here's all my presentation. Thank you.